So let's start. Yeah, welcome to my talk, using null type annotations in practice. My name is Brychcy, and I work for Mercateo. And I actually managed to change the other slides to white on black so you can see something. I hope it's readable, it's a bit blurry. These are the topics I will mention. I'd rather tell you than go through them now. Yeah? I just want to give a short update for those who were here at last year's EclipseCon and the presentation from Michael Vorburger. Was anybody there? Where he showed some Maven toolings especially, and also some M2E tooling to automatically configure the external annotations and the compiler settings in the Eclipse workspace. And they have made some progress. And if you haven't been there, it's also interesting. He also has the slides somewhere from last year's presentation. And yeah, they have now, for some libraries, they also now have external annotations. So go there. Yeah, we didn't use any of this because this is too new. So my presentation is about how we used it and some experiences and how you can use it. Then I also will show some new things in, that came in Oxygen and some things that will be coming in Photon. Because during using it, I also became a contributor and even a committer on JDT. So just to give you some reference, the code base is quite old. It's from 2002, the oldest code that I found that is still used. So this is interesting for people who want to start annotating existing code. Yeah? Our approach is not to start on the clean and do just everything like that. So we incrementally annotated this thing. Yeah? And we switched to the first time we used Eclipse annotations. If you look at it, it's 2012. This is actually 1 week after Eclipse 4.2 was released, which had it. Yeah? So we immediately started using it. We switched to null type annotations. I will explain the difference. Was a bit later. These are the type annotations that came with Java 8. And yeah, and to give you some statistics, in my workspace where I usually work, I have approximately 7,800 files. And I looked through it. Approximately half of them now have non-null by default on. Yeah? So still it's not complete. And we started 5 years ago, yeah, to give you an impression. Because we only annotate code if we change it for another reason. So there is no purpose in annotating existing code for us. Yeah? And we don't use package annotations. 2 reasons. There was no quick fix to conveniently do it. And also it creates too many warnings at the same time if you do it for existing code. It's a good idea to do it though for new code. So, and there is a quick fix coming for that. And just to give an impression, so how many nullables will you actually have inside this amount of files? So it's like on average 3 per file. Yeah? So null is really uncommon. Oh, no, 30. Still, it's not very common. Some files have many, but there are also like 800 files, if you look at it, which don't have any at all. Yeah? You can see it somewhere here, yeah? Because if you compare it. Yeah? And we also have some explicit non-null annotations. Actually, this shouldn't be, but we also have users of other IDEs, which understand them but don't understand non-null by default. Yeah? And what we also do use in certain situations, we just suppress the warnings. For example, in tests, it doesn't make much sense to annotate JUnit tests because you often explicitly break some null contract and yeah. Actually, why did we start immediately using these null annotations? Because even before, we had figured out it's stupid to have all kinds of null handling in code which doesn't really need it. So we came up with the convention, let's treat everything, all parameters and return types, as non-null unless we say so. So we even had Java docs like this, it's a leftover I found, where we just say which parameter will be null or which return type. In this case, this doesn't contain it. So this is, but you never get it right if the compiler doesn't use it and give you a warning. Why are you checking this? This is not annotated. Huh? So just to get to the results, in case I run out of time at the end, what we really like about null annotations in general, not null type annotations, also in general, is it's one thing less to worry about. You really think only about null if you need it. It's no. What if somebody passes in a null or so? Yeah, it's less complexity. Then obviously we don't have any NPEs in unannotated code. We also have fewer other bugs interesting, like somebody forgot to initialize a field or so. When I annotate code, I usually always find some bugs. Yeah? And a nice side effect is because the compiler cannot do anything. It likes some code pattern. You end up using some code patterns that also humans find easier to understand, yeah? Change and debug. So there's more benefit than only avoiding NPEs. Yeah? Then the disadvantage is sometimes it makes your code better. The compiler doesn't understand anything. You need to avoid some code patterns. And yeah, the syntax is a bit ugly with this Nullable. I like to elaborate on that because newer languages have a nice syntax on that. Yeah, like Kotlin, which has like in a regular expression, you just put a question mark after the string, and then it may be null, and otherwise not. Or Apple Swift has a very, very similar syntax. Actually, this is syntactic sugar for optional in Swift, yeah? but it's the same concept. Yeah? Or, which makes me hope, C#, Java's cousin, yeah? They announced for version 8 this syntax. Yeah? They really want to do it. They want to give users the possibility to basically configure non-null is not the default unless you say otherwise. I should think Oracle should look at that. Yeah. So what do I mean by null annotations? I already said it. I don't really think about nullable and non-null, because if you really start putting non-nulls everywhere, the code will be dead. What you really want to is you want to say non-null is the default, and I just annotate the nullables. Yeah? There are some exceptions, but in general, this is what you want. Yeah? For example, if you want to specify explicitly for a type parameter, then you need some explicit non-nulls. Yeah? And while you have some classes you can't directly put a non-null by default on, and it produces warning in other classes where you can do it, so then we start adding some non-nulls. Yeah? It's a pragmatic approach. So what's the difference between I hope you can, no, you cannot see it now. Ah, damn, I had to change the slides. So what do I do now? Should I make it back in black? No. Okay, imagine, because you can actually see the relevant difference. Yeah? Imagine there's an annotation declaration here, yeah? And you can specify the target. Where may I put this annotation? You can say this can be placed before fields, methods, parameters, local variables, yeah? This is actually the old style nullable declaration, yeah? For type annotation, you say you can put it on type uses. Everywhere a type is, like in a map, what does the map contain, yeah? And this is the difference. You declare where it is used. A type annotation, you have to explicitly say it's type use. Yeah? You can also define an yes, actually you half see it. You can also see declare an annotation without specifying the target. This means all declaration positions, but not type use. Type use you always have to say explicitly for your annotation. Yeah? And actually, in theory, it's possible to have like a mixed annotation, which you can put everywhere. So field, method, parameter, local variable, type use. But don't do that because of the array syntax. This is a bad idea. Yeah? They left it properly. They allowed it for some use cases which might need it, but null annotations is not a valid use case. So can you read this at all? Yeah, halfway works. There is a method name in here, yeah, method add. So this is how the dark theme looks with a white background. Yeah? You see all the places where you can put a declaration annotation before the return type, for parameters, before fields, and before local variables. In general, you don't need to put it before local variables, but you can to actually force, especially a non-null, to diagnose where does this null come from if you have a complicated expression or something. Yeah? The problem is, I hope you can see it, for lists, yeah, am I allowed to add a null to the list? This is the limit that you get with declaration annotations. It's way better than not having them, but it feels incomplete. You don't not get this to the state where you don't have to think about the nulls, because you still have that. Same for arrays. Now, okay, I have to flip these slides. It's very similar and it's hardly readable. With type annotations, you said, see, with type annotations, we now can reduce the scope of the non-null default to the same situation as previously. And there is a little change, because for type annotations, the nullable has to be in front of the array declaration, which you now cannot see here. Imagine there's an array here. And but to really annotate it, you can now say the contents of the array is maybe nullable. Yeah? The array itself may be nullable. Same thing for the list. Yeah? This list is not annotated. The list itself is non-null, but the contents may be nulls. Yeah? So this is good now. So non-null by default got extended by, I just saw Stefan. By the way, all these null annotations are the work of Stefan Hermann, who is sitting in the middle. Yeah? And the old version only had true and false, on and off. Now you can fine-tune it, which is very helpful. For example, if you find it very hard to annotate the fields, just say, I'll just use it for parameters and return types, which is a big gain already. Yeah? But if you look at it, you can now put it at parameters, return types, fields as previously. Type parameter, this is when you declare a generic. Type bounds, I'll explain that. Type argument, this is when you use it. If you say, yeah, I want a list of strings, and array contents. Yeah? And these are the default values. If you look at it, it's like as previously, parameter, return type, and field. Then you get type arguments. So if you specify generics, it will always be a list of non-null strings, unless you say otherwise, and type bounds. What's not in there is type parameter and array content. I don't know. Arrays are difficult because, like, for example, you cannot allocate an array of length 10 with non-null elements, because if it's new, it always contains nulls. Yeah? And also, I don't know why the choice was made, really. Maybe because it was not implemented. Now, type bounds. The type bound is if you have a type variable and you say it must extend some other type. Yeah? And this is this extend thing. Yeah? And to explain that, I first want to explain what's the relation between null annotations and objects. Yeah? If you think about it, if you say you have an object and you have a string, yeah? you can always assign a string to the object, but you cannot assign any object to the string. You'd need a cast. Yeah? So string extends object. Yeah? Now, if you think about nullable, you can assign the more specific one to the more general part, not the other way around. I can assign any string to a nullable string, but not the other way around. So what's the tricky part is actually nullable string is one more the null than non-null string. So actually it's a larger set, but it's the smaller set which extends the larger set in this case. Yeah, because you can assign any null string to a string. Yeah, and then you can, if you mix it, obviously a non-null strings extends a nullable object and so on. Yeah? What does this help us with type bounds? Yeah? Non-null by default is normally on for type bounds, but not for type parameters. So if I don't specify a bound, I most likely don't do anything with this object in my generics code. I just store it and return it to somebody. So in this situation, it's good if the user can decide, I want it nullable. Yeah? Sometimes you want lists or something which return null. Yeah? But if there is a type bound, like say I have a number list or I don't know what, yeah, then I most likely want to do something with the fact that it's a number, like compute the maximum, or I don't know what, yeah? And because of this choice that non-null by default works on the type bound, it effectively means if the bound is non-null, I cannot assign a null to the bound, so I never can have a type in here which is nullable. So effectively, if I have a type bound, the default means it's non-nullity. Yeah? So if I always I'm allowed to specify non-null types in here. But if I don't have a type bound, I can choose any type. It's a clever solution. Yeah? Question is, but I might want to specify a type bound and still allow the user to specify a nullable type. Yeah? And this is where the strange construct comes in, where you say it extends nullable that bound. Yeah? This is actually not a restriction, but it breaks the non-null by default here and makes it free again. Because you have an explicit specification, non-null by default doesn't kick in, so this becomes free with relation to null annotations. So you could now say I have a number list of nullable, double, whatever. Yeah? It's a bit hard to understand, but you get used to it. Yeah? Okay, this was the hard part. Now more about the experiences. Yeah? How we work is we always have a warning-free workspace, actually, yeah? Unless the code is fresh and we're working on it. And when we release it, we try to reduce it to 0 or maybe 3 things. Yeah? We always add non-null by default in new code. We add, like I said, non-null by default to other changes only when we work on it because of some other changes. To code, yeah, sorry. And like I also already said, we annotate related code. We always try to annotate the whole class, but sometimes you also only annotate some method. Yeah? Suppress warnings is okay for certain situations. And what we also wanted to have it should be usable for everybody in the company. It must not be too hard to configure. And there was no last npe.org, so we decided we only use external annotations. I'll explain them. For JDK, in one file configured on the workspace level. So you only have to configure your workspace to turn it on, and then it just works. Yeah? And when do we use suppress warnings? These are very typical examples. There's this generated hash code in equals, which you generate in the UI, and it contains a lot of null checks, which are unnecessary if you set the field is non-null. Yeah? And there's no point in trying to fix that. We just say suppress warnings, suppress warnings. Yeah? Then there are certain things that compiler currently can't understand. These cool Java 8 stream APIs, if you have a stream of nullable things, and then you put in a filter that the object should not be null, then effectively you get a stream of non-null things. The compiler doesn't understand that. So yeah, we also put a non-null suppress warning in this case and simply on the statement. Yeah? On the statement level, you can put non-null by default before suppress warnings before local variables, and then you get rid of that. There's a similar situation with optional, which has a they made a mistake with optional that you are allowed to specify nullable values in the same method. This was right in Guava, and they improved it in the wrong direction. It's very disappointing, but it's a bad idea to mix optional and null anyway. So we just put suppress warnings on that in that case. Then we also, obviously, tests are a good place not to waste time. Just put suppress warnings on the whole class. Yeah. But still add non-null by default. Sounds strange, but it makes sense because the new Eclipse Oxygen understands it and then doesn't generate non-nulls and when you refactor the code or extract local variables or anything. Yeah? And then we used to add suppress warning also for the case when we like a comparator or anything where we cannot annotate the base class. No, comparator is a bad example. Sucks callbacks, yeah, and then we just do it locally. Yeah? It's better than not annotating the class. Yeah. So now I'm going to show you how we configure our workspace settings. Yeah. Let's simply start. Yeah, hardly readable, but maybe you can see. We basically have everything on warning. Like I said, we work warning free anyway, so these are like errors to us, except we ignore the package thing, yeah, that you are supposed to put non-null by default on the package. We ignore redundant null annotations because of other IDEs. And which still can make use of the null annotations. Yeah, it's also good with these, for these team members. Unchecked code. This is a very important change, thing, to not get too many warnings. In older Eclipse versions, we had it simply off. Now we have the info level. So you can see when an unchecked type is one where the compiler doesn't know if it is non-null or nullable. Yeah? So you get a little blue line in the editor, but you can figure the problems view so it does not show any trace of this. Yeah? And also, by the way, for annotating, it's really important to have the warning on about redundant null checks. Yeah? This must be on, or you won't get any quick fixes to fix the parameters. Because most of the time you check some parameters, yeah, and you tell you, why are you checking the parameter? And you say, because it's nullable. And then you say the quick fix, and then that's it. Yeah? So, and now also, hardly readable. These are the annotations configuration. You should really configure third-party annotations like JavaX annotation, the non-really standard annotations that, for example, Guava uses. Yeah? And then what we actually did is, you can maybe see it, we have our own copy of the null annotations. This is quite useful. You don't have to use JDT annotations. It's only the names and how they are configured that is important. Yeah? And why do we have our custom annotations? First thing was, you can choose your own default values. Yeah? For example, in Mars, I noted that these type-bound things didn't really work. And I simply took the default out, and we happily annotated without this. Yeah? Until all the bugs were fixed. Or if you have code where you cannot annotate the fields, yeah? Make your own non-null by default. Actually, I think you can even do secondary non-null by default annotations for different combinations. It just has the disadvantage that the IDE only understands the first one and might generate redundant non-nulls. Yeah? Okay, then you can change the retention, yeah, for the null annotations. Normally it's class file only, so you cannot see it at runtime. This is also something we did for testing frameworks. Yeah? And probably the most important part is those users of other IDEs, they find it strange culturally if you have not Eclipse in this import. So now it's our company name. Yeah? Simple trick. Okay. Then I said we have Workspace-wide EEA. Actually, I could try to simply show these in the EDE. It's easier for more visible. Let me see. You may have noticed I'm usually use the black theme. Okay, let's quickly change to the white theme. Better, huh? Okay. The external annotations, yep. The installed JREs, we do it on a workspace level. Yeah? You go into installed JREs, then you click on this, edit. Now it's Java 9. Yeah? In the Java 9 case, it's a bit simpler. You get external annotations here. And then you basically pick a folder. Actually, it's in the workspace. I don't know why it's now called external allocation. Well, but basically, it's actually a workspace folder in this case. Yeah? For Java 8, it will be more difficult. I'll show it. Because you have this long list of jars. But the one you need is the RT jar, like runtime probably. Yeah? You would have to add it here. This is where all the important classes are. Yeah? I can actually do it. Just show it how you do it. You go here. Then I have our folder here. Oops, no. I think it's a directory in there. So yeah. If you peek inside, then this is where the package names start. Yeah? And that is it. And now this works in all projects in your workspace. Yeah. Actually, a little warning, if you enable annotation-based analysis in the workspace level for everything, and you have a project in your class which does not have these null classes, there are certain code patterns that trigger a compiler bug where you might see the class nullable is indirectly required by class files and it's missing. This is already fixed in the newest builds, but in this case, either add them to the class path or simply turn this off for the project. Yeah? Okay, where was I? Another nice trick is that you can, I'm not going to show this, just point it out. You can make code templates, and simply making a code template for a new Java file, which has the non-null by default already configured, is a big improvement somehow. You stop forgetting it. Even I forgot it after a few years, and once I did this little change, you live in a non-null by default world. That's cool. And if you, another cool trick, you've probably seen it at this EclipseCon, there are these favorites, which always provide static imports. Because the completion for enum values doesn't provide show you the enum constant if the value is an array, and you can work around this by simply configuring those default location constants here. I have a patch for that in the work actually. This won't be necessary starting with probably M4 or so. Yeah? Okay. Now, is using null type annotations only easier than declaration annotations? No. There are some quirks. One of the things is the syntax. If you have a qualified name, you have to put the annotation at a very unexpected place. Almost everybody gets hurt by that. Yeah. There's a new quick fix for that, which came in Oxygen. And the syntax for arrays has some disadvantages. Yeah. The problem is, say you have a declaration annotation. You half saw the slide earlier. Yeah. You saw in a declaration annotation, the nullable or non-null, whatever, was in front of string. Now, if you switch to type annotations, this is the location where the content of the array is now specified. So suddenly, if you just change your class file and suddenly use null annotations, a nullable array gets turned into a non-null array of nullable. Yeah? This is bad. And this is actually the hardest part during migration. Yeah? This is actually the only really hard thing. Yeah? We used some regular expressions, which did like 90% of the bugs, the cases. I think I didn't catch the combination of arrays and these. But this is ugly. Yeah? So if you start now, start immediately with type annotations and everything's good. Yeah? And then the previous state was that if you didn't just turn it on and didn't annotate anything, you wouldn't see any errors. This changes. If you turn on type annotations, you suddenly may start seeing errors. Or especially if you, there are some problems like a class literal is implicitly non-null, and then if you invoke a generics method, and which isn't annotated, it might suddenly say, why are you checking the result, and so on. And what you also need, you could live without external annotations in the age of declaration annotations, but not now. With type annotations, you really must have them simply because of one method, and this is map_get. Everybody's using it, and if you have a map of string, no, it's a map of non-null string. So the compiler substitutes the type of the value, which maps to string, and says, okay, this map is returning a non-null string. And then you will have warning for all those places. Why are you comparing this result with null? So you need at least one external annotation. I already thought maybe we should build it in or something for this method. And I showed you how to configure it. It's not hard. This was the array syntax thing. Then the other problem I already mentioned, you also cannot create new arrays of non-null, And there's one question. You often have utility methods. And if you think about it, I tried to show it earlier, but it was a bit invisible. You cannot simply pass a method which takes an array of nullable strings, an array of non-null strings, because the method might change it and put a null inside. So what do I do if I want to make a method which takes both? Because usually if you just read it, obviously you can also take an array which just contains non-null values. And there was a bug for that. And then actually Stefan came to the solution, hey, let's use a type variable. Yeah? The set is exactly this behavior. Yeah? You can say any type you want. And the compiler has to assume that you may pass a nullable or a non-null type. Yeah? And you are only allowed to read. You might get a null. You have to live with nulls. You have to check for them. But you're not allowed to store the non-null value. Yeah? And there was a little quirk of this before Oxygen, because if you think about it, if you don't have a nullable in here and you have something like strings, can you see it? It's t extends string. And what would happen? You would get a warning because strings is a final class. So yeah, you can do that now. If there's a type annotation, you won't get a warning. Yeah. Okay. Then what you will see if you annotate existing code. Yeah. There's the code which doesn't do anything. It just uses the parameters and you don't know anything. It's actually quite easy to annotate, bottom up. Yeah? The hard part is code which tries to avoid nulls. Yeah? If any parameter is null, let's just return null so I won't throw an MPE. This generates nulls, and it's a bit hard to annotate. What we often do is that we make a second copy of the method, rename the original one if possible with null, and then only use the one which doesn't do this. Yeah? Then there are also developers who basically place objects require non-null for every parameter just to be sure. Very easy to annotate, it's okay. The worst code is which does something with this and catches all exceptions. I've also seen that. Yeah, yeah, very rare, but happens. Yeah? And then basically what we now did is that we do it in a Java doc. That's easy to annotate, obviously. Now, it's small, but maybe you can read it. What are antipatterns in this respect? You have to understand the compiler only looks at the local code, at the local method. And so it doesn't do any interprocedural analysis. For example, it cannot see if you evoke an init method that this init method would initialize your non-null fields. Yeah? Or we have some is-valid methods which also test that the parameter is nullable. It's not null. Yeah? You cannot do that. Yeah? Then there's no correlation analysis. Yeah? For example, this is actually code I saw almost like that in the Java compiler. This is the reason why the Eclipse Java compiler doesn't use null annotations itself. Maybe where the array length is simply used or null to set some length variable. But if the array is null, it's just null, and then you use that in a loop. So the compiler would now say, oh, hey, this array can be null. Why are you accessing the array here somewhere in the loop body? Huh? Just avoid it. Replace it by an if statement and then skip the loop. There are certain kinds of callbacks where you say, let's start. Then it puts all kind of data in the field, and the next call will use that data without check. Compiler cannot do that. Yeah? Some kinds of builder patterns. Yeah? What's obviously good is final fields. The compiler doesn't look into other methods, but things that are immutable cannot change. So it's easy to annotate, and yeah, especially if the object itself is completely immutable. Yeah? Then what you can really often do is just don't use null. Use an empty string if you don't have the value. Yeah? Or use an empty collection. Or use a no-op implementation of some service. Yeah? And we also introduced the convention of avoiding null literals. We simply define a constant null. So you have class.capital null. This is type safe. You can find references on it. Yeah? And it really reduces this null usage pattern also. Yeah? Oh yeah, time's running out. That's like, okay, no, I'll come back to that. There is Java optional. Do I need null at all? Yeah? I'd say, some people say I don't need nullable at all. There's optional. But you have to think about it. It's really only for return types. You don't want to wrap something into an optional. The user doesn't want to do it when he invokes a method. Yeah? And you also cannot override a method which takes an optional, which returns an optional to say, no, I always return the value. You can do that with null annotations. The other way for the parameter, if the method says this parameter must be non-null, I can override it in my class and say, locally, I also accept nullable parameters. Yeah? Then optional is hard to add. It's not serializable. Yeah? And yeah, So I say it's a different solution for the same problem. Best thing is to use both simply. Yeah? Put non-null by default on the class, and then you know you really don't have no problem because of nulls. Yeah? The only problem was this with or else problem. Yeah? So that's how it is. Yeah? Actually, I'm coming to the end. Yeah? The list of improvements in Oxygen, if you looked at the new and noteworthy, was quite short. Actually, the only thing that was actually mentioned was a quick fix to fix that problem when you put the annotation in the wrong place. But you're looking at it, there were 55 bugs fixed. Yeah? And I'd say Oxygen is the first release where these null type annotations are really usable and complete. Actually, some things were completely missing, like the default location array contents was simply not implemented. Yeah? There were not too many bug reports. Hardly somebody ever used it. Also, yeah, you can now put non-null by default in front of fields or local variables. It's mostly used to cancel it actually. Yeah? But this was also not implemented. It was always documented. This is why we didn't put it into the new and noteworthy. Yeah? But it's now there. Yeah. And this little thing I explained is already there. And now something cool. I don't have the time to show it. Maybe I can show it to somebody now. Now the UI understands non-null by default in the most important quick fixes and refactorings. It's quite a lot of them. Yeah. Extract local variable used to add redundant non-nulls. Yeah. The right side is not visible actually. The list went on. It's twice as many. Yeah. There are many fixes which now do not generate redundant non-nulls. Yeah. A very quick preview to Photon. Yeah. Now you can add non-null by default to the packages, even to multiple packages at the same time, which is cool for experimenting more than using this. You can also undo it in a little change. You just have to select the package explorer for the undo. Stefan showed it. This might be obsolete again because you can put it into the module info in Java 9. It's not committed yet. Yeah. We are discussing, no guarantee, maybe we'll support third-party non-null by default annotations. Yeah. For example, Spring has one, which uses this type qualifier default. I'll continue. It's not all quick fixes avoid this generating non-nulls, but yeah, most of them do. Yeah. Thanks. Sorry for the visual problem. Questions, comments? Yeah, Michael.
You are putting your external annotations directly at the JRE definition. We are adding them to the class path of each project. Do you see any benefits or?
We wanted to simply make it easy for everybody so he has just to once configure his workspace and that's it. Yeah. This is the only reason. This was the way of least resistance to make everybody use it. Also, we have different locations, and some of our other locations people are not using it as much as us. Yeah, so. Yeah. Anything else?
And those external annotations, they're from the last annotation.org. That's where we can get them.
Yeah. Yep. No, we made our own because they didn't have it then. But now I would use them. I am the only one in the company who's prototyping their tooling now. Yeah. I use them in addition to our own ones. Yeah. Okay, then thank you.